traffic sign and lane detection using cascaded networks. Our project aims at recognizing traffic signs, identifying the lane marks. Such systems have the goal to detect the lane marks and to warn the driver in case the vehicle has the tendency to depart from lane. This project aims at recognizing traffic signs and lane. This system is used to detect and classify one or more road signs from within live color images captured by the camera. This project also aims at identifying the lane marks. Lane detection systems are useful in avoiding the accident as safety is the main purpose of the system. We are building the solution for the smart cars which informs the driver about what traffic signs are detected, and if some traffic signs are not properly visible, then it matches the pattern with sample image trail. Technology uses machine learning and image processing. Machine learning is an application of AI that provides system the ability to automatically learn and improve from experience without being explicitly programmed. The images are fed as input and the system is made capable of identifying the images. As the project which we need to build concentrates on smart car, which is a developing field in automobile and tech industry. Prediction of warn or damage sign cannot be done. Change of lane detection during driving is difficult to predict. Initial step is to train model with many sample of image of traffic signs. Then we use the image captured by the camera present in the car. We fed this image to the trained model. We use TensorFlow to build the neural networks to process the image to detect the traffic sign. Traffic lane is detected using image processing. TensorFlow is an open source software library for high performance numerical computation. Its flexible architecture allows easy deployment of computation across a variety of platforms like CPU, GPU, TPU, and from desktop to cluster of server to mobile and edge devices. In machine learning, a convolutional neural network CNN or ConNet is a class of deep feed-forward artificial neural networks that has successfully been applied to analyzing visual imagery. Convolutional networks were inspired by biological process in that the connectivity pattern between neurons resembles the organization of the animal visual cortex. This is the architecture of CNN.
First, the input video is being inserted and it is being converted to grayscale. The sign which is cropped and fixed to the screen, it is passed to the sign classification to classify. It is matched with the training data which has been trained earlier and the output is given. Hardware components are CPU of Pentium 3 or higher, RAM 4 GB, GPU 2 GB and a camera. Software components are Ubuntu 14.0 or higher, Python 3, TensorFlow. Design of traffic sign detection, recognition and transmission systems for smart vehicles. Smart sign detection and recognition is an essential component of advanced driver assistance systems. It is mainly designed to enhance driver safety through the fast acquisition and interpretation of traffic signs. Finally, the transmission of the recognized signs is briefly investigated. Applying a functional network to real-time lane detection, most traffic accidents resulted from distraction and driving fatigue. In order to protect drivers, a real-time lane detection system that uses a mounted camera inside a vehicle has been designed for safe driving. The experimental result shows that the system works successfully in real-time environment. Traffic sign detection based on cascaded convolutional neural networks. The local binary pattern feature detector and the ADA-boost classifier are combined to extract regions of interest for course selections. Next, cascaded CNNs are employed to reduce negative samples of traffic signs for traffic sign recognition compared with conventional CNN. Our CNN contains 3 conventional layers and its classification part is replaced by the support vector machine. The German sign detection benchmark is used and experimental results demonstrate that the proposed method can achieve competitive results. It aims at recognizing traffic signs and lanes. Lane detection systems are used to avoid accidents as safety is main purpose of the system. System must have goals to detect the traffic signs. A laptop with GPU, miscellaneous and totally 47,000. Since we are implementing the project using machine learning, which is a future technology, AI is the future doing a project on the would be game change in the industry. As explained in the aim, this project would be very helpful in automobile industry as many are thinking of automation.
Hello, now I would explain the lane detection project. Initially, we have considered the matplotlib and MoviePy for our reading the input and output from the different files. And initially, for an image, from an image to identify the lane, we place the different images that are present inside the folder, and we use the list directory to represent which folder we want to read, and we will read all the files that are present in that directory. These are the files that are present in that directory, and we use the different functions that are grayscaling is to convert an image to the grayscale format. Canny was used to detect the edges that are present in the image, and Gaussian ruler is to highlight the straight lines that are from the image, and ROI region of interest that mask the vertices using the dimensions, and next, text lines is a main method which we call. Here we pass the images that are to be from which the lane must be identified, and initially if we look at the lane, only a small part of the lane is selected. We want the overall pattern of the lane, so what we do is we average the lines, that is we want to extend the lines so that it would appear more good for the user. Now after calling this after averaging, we get a lane that is very much accurate and could be identified easily. These are the outputs for the given input images. And now if we consider the video as an input, then we call that file solid white lines that is present in the test video folder, and the output is saved in the test video output. And here we call the detect lines method. Here all the frames from the video would be passed to that image, then it would be a lane would be identified, and the video would be built as an output, and that would be stored in that test video output directory. This is the video that has been generated. Now for yellow lines and white lines, for yellow lines that are present on the video, that is the left or the rightmost corner lane, we give that video as an input, and we will call the method detect lanes, that is the main method, and each and every frames of that video would be passed, and it would generate a video and would be saved in that particular test video output directory, and this is the output that is generated. Thank you. self-driving car CNN based traffic sign recognition. Initially we need a huge amount of images for training, so we have considered the German traffic sign dataset that is already in the pickled format. And this, what is this pickled format? Pickled format is it is an array that stores an different images in the form of an array. That is, it contains the features, labels, size and coordinates. And what this training data consists of? This training data consists of 39,000 training images and about 12,000 images for testing. Now plot figure method is used to plot the graphs and to show the images, output images. And here, if we see this graph, we have about 42 different traffic signs. Initially, sign 0, that is one traffic sign that contains about only 250 samples. And so similarly, for testing, we have same traffic sign 0 as the count of that is very low, 50, about 50. So the training data is very less, so we would not be able to achieve the greater accuracy. So what we do is we augment and grayscale the image. Initially, that is the process of generating the fake data from the original data. So after first, initially we will generate an grayscale image from the original RGB image. That is, we convert this training data of 32 by 32 and in RGB format into a grayscale image, and we would replace our training data with the grayscale image and testing data with the testing grayscale image, and validation also similarly. And we want to make a duplicate copy of our data. So what we do is we change the perspective of an image, we rotate the image so that the count of the image would be increased in the training data set. After increasing, what we have got is traffic sign 0 is about 1200 images, and similarly traffic 1 sign count is about 2600, and the testing data we have kept the same, we have not changed it. And then we normalize the image so that we will get a greater depth of images, and then the testing data and the training data would be replaced with the normalized image. And this is the structure of the CNN what we have used. Initially we give an input of 32 by 32 inches and grayscale image, and we use a convolution 5 by 5, and it creates an output of 22 by 28 by 28 pixeled images, and we activate those layers using a Rayleigh activation, and we use a max pooling. Similarly, we have two hidden layers and fully connected two layers, and this is how we create the neural network. And initially we have to do the training, so I have kept the epoch count to 2, and the batch size is about 256. 256 represents 256 image samples are being passed for at a time for a CNN, and it's a learning rate about 0.00097, and here we call the training. And evaluate method is used to find out the accuracy of the training testing and different values. See, after training of each epoch we get testing accuracy. For one epoch we got a testing accuracy of 0.888, that is 88%, and validation of 86%. For a second epoch we got a testing accuracy of 96% and validation of 93%. Those models have been saved, and this is the loss of values loss which we have encountered that are saved in a graphical format. And We have kept our traffic signs in the particular folder called my signs, that all the images are in png format, and these are the indices of the traffic signs, and we show the different signs that are present over in that folder. And from our previously trained data model, we got a data accuracy of 1. This process includes only we have completed only the training one. Now for testing, initially all the process is similar, and here for our performance analysis, we called all the images that are stored, and we convert those images into grayscale format, and we normalize it, and that image is passed to the CNN. And from our stored model, we for our first image we got a training accuracy of 1, that is we have it has been identified properly or at a average of 100%, and similarly for all 8 images. And if we wanna compare what we have obtained or what it has been guessing, the original image was about of 30 speed limit 30, and what it guessed is also the speed limit of 30 with 100% accuracy, and bumps 100%, move ahead, forward, and or can left diversion, caution, around about, stop. Those all are images have been properly identified. This accuracy of greater accuracy was obtained only by converting the images into grayscale and normalizing it. If we directly use the RGB format, we need to train more, and we have to give more input samples. That is very much difficult to handle by our commodity hardware. So so we have converted this all the images into grayscale, and we have achieved a good accuracy in our project. And